Hi, everybody. My name's Tony, and this is my first video for my new YouTube channel. And basically, what I want to do here is show you my Orrery project. So you may wonder, what is an Orrery, right? An Orrery is a model of the solar system. Um, you may have seen old style mechanical orreries. It has like a uh, little spokes around it connected to little balls that represent the planets and set up mechanically so that the orbits are kind of aligned with each other. So for one orbit of the Earth ball, the Mars ball will go about half an orbit, and the Venus ball will go about an orbit and a half, something like that. And these old mechanical orreries were, very cute and appealing and interesting. Um, but today, we're using modern technology. We can do way better. But of course, it's not a mechanical orrery; it's a digital orrery, right? Um, NASA's Jet Propulsion Laboratory, that's located at Caltech in Pasadena, California, has this computer system called Horizons that is just truly amazing. I'll show you at some point what that looks like. But basically, what it does is it has a depository of all kinds of data regarding celestial objects and spacecraft. Mostly NASA spacecraft, but not just also European Space Agency and some others, Japanese uh, craft, etc. So it's very phenomenal. And the other thing about Horizons is that it's current. So, for example, if you want to visualize the orbit of the Earth, something basic, um, where is it positioned in the solar system? It has the data to do that. And you can fetch current data about the position of all these objects relative to each other, the Earth, the Moon, Mars, Jupiter satellites, the spacecraft that are going to Jupiter, the Juno spacecraft, the Cassini spacecraft. We could even look at certain historical spacecraft like Apollo, for example, and certain components of Apollo, and some of the really amazing spacecraft like the Voyager 1 and Voyager 2 spacecraft that are at the very outside edges of the solar system. You can actually visualize where they're at and track them, and you can actually project their trajectories into the future, go back into the past. You can do all kinds of great visualizations. So in my orrery, basically, that's what I try to do. And to add even a little bit more, I've also have a part of it that visualizes our stellar neighborhood. So in other words, um, there's different ways of visualizing our stellar neighborhood. One is by distance, like, okay, so I set it up so you can see the stars in near the sun up to 100 light years. And I might extend that beyond that, but right now I have it up to about 100 light years. And the other way you can do it, which is really interesting, is um, to look at stars at visual magnitude. So um, visual magnitude is basically how bright they look, There's a big difference between absolute magnitude and visual magnitude. Absolute magnitude is how bright the star is intrinsically, how luminous it is. But, just because it's luminous doesn't mean you can see it if it's very far away, for example, right? Or a different galaxy, it doesn't matter how luminous it is, you may not be able to see it. But apparent magnitude is what we actually can see from Earth. So the brightest stars and so forth, right? So, and astronomers have a scale for how bright stars are, starting at like something like -2 or something like that. It's weird, the negative numbers are the brightest, and the higher the positive numbers, they're the least bright. So typical brightness might be up to a visual magnitude of about 4. Like say in a urban environment where I live, um, typical limiting magnitudes would be around 4. Anything beyond that, you're probably too dim to see in an urban environment. If you go out into the countryside, you can see 5, 6 in a truly exceptional site like the Chile Atacama Desert or Antarctica or something like that, um, or the Nubian Desert, for example. You might be able to see magnitude 7. And out in space, like say we're at in the space in the International Space Station, you might be actually able to see even more than that, maybe magnitude 8. Although I don't know if that's been documented. But yeah, so that's the main idea behind my Orrery. And I'll be posting other videos to actually show you what that looks like. But this is just an introductory video of what my project is about. Thanks for watching. Bye now.